Melday's experiment. Melday's experiment is something to do with stationary waves. This is a solenoid connected with AC source. Alternating waves are produced here. Then one rod is there in between, connected with the string passing over pulley, and this is possibility of putting on the weights. You see, instead of this AC source, we could use the changing polarity options also, but that will know not so fast. That's why, since we are interested in changing the polarity of this magnetic solenoid, we prefer, instead of this DC source, what we do, we use AC source. Clear reasoning, I have told you why we are using AC source. AC source of lower frequency, then it will become magnet, no doubt, but with the changing polarity of AC, its pole will also go on changing. One time it will become north, other time it will become south. With its changing nature, the rod inside will also start vibrating. When the vibration would take place in this string, vibration will take place, it will reflect from the pulley and a stationary wave will take place. You see, the tension that have been produced here will be known with this help, T equal to mg. This is the tension that is produced here. By counting the number of loops and the tension that has been produced here, you will find in different cases that the product of P1 root T1 becomes equal to P2 root T2. That means, in general, we could say P root T is constant. This is what we call Melday's law. Melday's law is nothing but it is regarding the connectivity of the tension in the string and number of loops possible. P is the number of segment, or you might say the number of loops in the string, and this T is the tension. Since in stretched string, you see, the formula for the fundamental frequency is given by this relation. We could derive, or we could formulate various laws from this very equation, like you could say n is proportional to 1 upon L, but all these laws are going to be conditional. You relate these two, obviously you have to consider remaining to be constant. So, this is optional, this is mandatory to say that T and M are constant. Likewise, you could say n is proportional to 1 upon root m, but here again you are going to add that T and L are constant. So, you can formulate 5 laws. You could break it up into m as pi r squared d. So, you could talk in terms of radius and density as well. So, as far as if you want to increase the number of laws, you could do it, but you have to be alert only at this juncture that you consider one, establish the relation and say the remainings are constant, as I did in the case of this linear density. I related with frequency, then I strictly I said that T and L will be constant. Likewise, if you write in place of m pi r square d, then also you could relate n with r, and again you would say that remaining, that is L, T and D, are going to be constant. These are known as laws of string. Then sonometer is quite similar to, you see, as there in the case of longitudinal wave, we perform the experiment with the resonance tube or Kunz tube. Here, analogous to them is sonometer. Sonometer uses transverse stationary wave. We use two knife edges and pass the string over them. Then at one end of the table we have, or the bench, we have one pulley above which the string goes on. One end of the string is always fixed. Between these two knife edges, the effective length is considered, In fact, the total length is not going to oscillate, and that is not of a point of concern for us. We consider this effective length. We put here some weight, and its load or the gravitational weight is capable of producing the tension in the string. We bring the oscillating tuning fork, its stem is brought in contact with the tables, floats somewhere, then obviously the waves will be produced in the string also. During resonance, you see we put some papers piece over here. During resonance, you know, the amplitude obviously increases very much, and in that case this paper piece will also start moving vertically by a greater amplitude, and it will indicate that resonance has taken place. In that case, you are going to note the reading, and the formula will finally, this will tell you what is the frequency that you are interested in. You know the effective length, you must be knowing the linear density of the wire that has been used. T could be calculated with the help of this. You see, if the same experiment is performed in water, means this load or the block is immersed in water, then its effective weight is going to change. So, the same experiment if performed in water is going to lead to some different reading because of the effective change in this weight.